this section, we are continuing the quick revision about quadratic equation. First question, which of the following equation is quadratic? We know that the general form of a quadratic equation is ax square plus bx plus c is equal to 0. So, let's check with each equation. Equation number 1, x square plus 2x plus 11 equal to 0. This equation has only one variable x and its highest power is 2. And this is in the form of ax square plus bx plus c is equal to 0. That means this equation number 1 is a quadratic equation. Now check with equation number 2. X square minus 2x plus 5 is equal to x square. How we can rewrite this equation? X square, move this x square to left hand side, it's become minus x square minus 2x plus 5 equal to 0. X square and minus x square cancel and the remaining is minus 2x plus 5 equal to 0. That is, in this equation, the term containing x square is missing. The highest power of the variable x is 1. That means equation number 2 is not a quadratic equation. Let's check with third equation. X plus 2 the whole square equal to 2x square. What is the first step? Expand this term, x plus 2 square. It's become x square plus 4x plus 4 equal to 2x square. Therefore, we can write it as x square minus 2x square. It's become minus x square plus 4x plus 4 equal to 0, or we can, if we multiply it with minus, then it's become x square minus 4x minus 4 equal to 0. X square minus 4x minus 4 is equal to 0. This is in the form of x square plus bx plus c is equal to 0. Equation number 3 is also a quadratic equation. From the given 3 equation, equation number 1 and equation number 3 are quadratic equations. Next question. Find the value of discriminant of the following equations. 3 equations are given. Find the discriminant of each equation. We know that discriminant d equal to b square minus 4ac. Consider first equation, 2y square minus y plus 2 equal to 0. Find out the value of d equal to b square. Here b is minus 1. Minus 1 square minus 4 into a. A is 2. C is 2. Minus 1 square. Minus 1 square is 1 minus 4 into 2, 8. 8 into 2, 16. 1 minus 16 is equal to minus 15. 1 minus 16 is equal to minus 15. The value of discriminant for this equation is minus 15. Second equation, 5m square minus m equal to 0. Write down the coefficients a equal to 5, b equal to minus 1 and c is equal to 0. Here the constant term is not present. That means C is equal to 0. Value of D equal to B square. B is minus 1. Minus 1 square minus 4 into A is 5 into C is 0. Minus 1 square is 1 minus 4 into 5, 20 into 0 is 0. That means 1 minus 0 equal to 1. The value of discriminant for the equation 5m square minus m is 1. If constant term is not present in the given quadratic equation, the value of D is B square. Then take third equation, root 5 x square minus x minus root 5 equal to 0. D equal to B square. B is minus 1. Minus 1 square minus 4 into A is root 5 and C is minus root 5. Minus 1 square is 1 minus 4 into root 5 into root 5 into root 5 5 minus 5 into 4 is minus 20. Minus of minus 20 is plus 20. Minus of minus 20 is plus 20. Then 1 plus 20 is 21. The value of discriminant D equal to 21 for this equation. Next question. One of the roots of quadratic equation 2x square plus kx minus 2 is equal to 0 is minus 2. Find k. If minus 2 is a root of this quadratic equation, that means it satisfies the value minus 2. That means P of minus 2 equal to 0. The quadratic equation is 2x square plus kx minus 2 is equal to 0. Then P of minus 2 is, in place of x, substitute the value minus 2. 2 into minus 2 square plus k into minus 2 minus 2. Minus 2 square is 4. 4 into 2, 8. K into minus 2 is minus 2k minus 2 equal to 0. Therefore, P of minus 2 is equal to minus 8 minus 2k minus 2 is equal to 0. Therefore, we can write 8 minus 2 is 6. 6 minus 2k equal to 0, or we can write 2k equal to 6. Therefore, the value of k equal to 6 by 2 is equal to 3. The value of k equal to 3. Next question. Two roots of the quadratic equations are given. Frame the equation. 3 set of roots are given. Take the first one. The roots of a quadratic equation are 10 and minus 10. 10 and minus 10. If the two roots of a quadratic equation are given, then how we can frame its corresponding quadratic equation? Using the relation x square minus sum of roots into x plus product of roots equal to 0. Here Sum of roots is sum of root equal to 10 plus minus 10. 10 plus minus 10 equal to 0. Product of roots, product equal to 10 into minus 10 equal to minus 100. Then how we can form its corresponding quadratic equation? X square minus sum of roots 0x plus product of roots is minus 100 equal to 0, or simply we can write x square minus 100 equal to 0. If the roots 10 and minus 10, then its corresponding quadratic equation is x square minus 100 equal to 0. X square minus 100 equal to 0. Take the next roots. The roots of quadratic equation are 1 minus 3 root 5 and 1 plus 3 root 5. Sum of roots equal to 1 minus 3 root 5 plus 1 plus 3 root 5. That is equal to minus 3 root 5 plus 3 root 5 becomes 0, and 1 plus 1 is 2. Then product of roots equal to 1 minus 3 root 5 into 1 plus 3 root 5. 1 minus 3 root 5 into 1 plus 3 root 5. This is equal to a plus b into a minus b form. A square minus b square. B is 3 root 5 square, or that is equal to 1 minus 3 root square of 3 root 5 is square of 3 is 9. 9 into root square of root 5 is 5. 9 into 5 is 45. 1 minus 45 equal to minus 44. Sum of roots is 2 and product of roots is minus 44. Then form this quadratic equation: x square minus sum of roots 2x plus product of root is minus 44 equal to 0. We can write the quadratic equation as x square minus 2x plus of minus 44. It's become minus 44 equal to 0. Consider next pair of roots, 0 and 7. Sum of roots equal to 0 plus 7 is 7, and product of roots 0 into 7. 0 into 7 is 0. Then its corresponding quadratic equation is x square minus sum of roots 7x and product of roots plus 0 equal to 0, or we can write x square minus 7x equal to 0. We can say that 0 and 7 are the roots of the quadratic equation x square minus 7x equal to 0. Our next question: determine the nature for roots of each of the quadratic equation. 3 quadratic equations are given. Determine the nature of roots of each quadratic equation. Take the first quadratic equation. 3x square minus 5x plus 7 is equal to 0. We know that the value of the discriminant b square minus 4ac determine the nature of roots of a quadratic equation. 3x square minus 5x plus 7 equal to 0. Find its value of its discriminant. D equal to b square minus 4ac. Write down the value of its coefficients. A equal to 3, b equal to minus 5 and c is equal to 7. Then b square minus 4ac is minus 5 square minus 4 into a is 3 into c. Minus 5 square is 25 minus 4 into 3 12, 12 into 7 84, 25 minus 84 is equal to minus 59. The value of discriminant is minus 59. That means it's a negative value. If the value of discriminant is negative, means that the root's nature is there is no real roots for that quadratic equation. So, for this quadratic equation, no real roots, because the value of the discriminant is a negative value. Take the second quadratic equation. Root 3 x square plus root 2 x minus 2 root 3 equal to 0. For our easy calculation, write down the coefficients. A equal to root 3, b equal to root 2 and c is equal to minus 2 root 3. The value of b square minus 4ac equal to b square root 2 square minus 4 into a root 3, c is minus 2 root 3 equal to root 2 square. Root 2 square is 2 minus 4 into root 3 into minus 2 root 3. Then it's become positive. 4 into 2 is 4 into 2 into root 3 into root 3. 4 into 2 is 8. Root 3 into root 3, 3. That means 4 into 2 into 3. 8 into 3, 24. 2 plus 24 equal to 26. The value of discriminant b square minus 4ac is 26, means it's a positive value. If the discriminant of a quadratic equation is positive, means that quadratic equation has two real, distinct or unequal roots. Two real unequal roots for this quadratic equation, because the value of its discriminant is a positive value. Consider the third equation. M square minus 2m plus 1 equal to 0. Write down the coefficients. A equal to 1, b equal to minus 2 and c is equal to 1. Value of b square minus 4ac equal to b is minus 2. Minus 2 square minus 4 into A is 1 into C is also 1. That is equal to minus 2 square is 4 minus 4 into 1 is 4. 4 minus 4 equal to 0. The value of discriminant is 0 means that quadratic equation has two real equal roots. Two real equal roots for this quadratic equation, because the value of its discriminant is 0. For the first quadratic equation, the value of its discriminant is a negative value. So we can say that for that quadratic equation there is no real roots. For the second quadratic equation, the value of its discriminant is a positive value. So that quadratic equation has two equal, distinct or unequal roots. In the case of third equation, the value of discriminant is 0. So we can conclude that that quadratic equation has two real equal roots.